We're talking about this symbol, okay? Absolute value allows you to measure distances without having to have negatives. Put your foot down, please. Thank you. Okay? So if I wanted to say that if I'm on a number line, which I know you guys all did a lot of this stuff before on number line stuff. Let's say B is at 13 and A is at 6. All you would do is figure out the distance between the two. You'd say it is 13 minus 6, and we take that absolute value. Absolute value stands for the distance from 0, how far away something is from 0. That's why it's always positive, because you can never measure negative amounts. You guys have heard that before, right?
What?
Thank you. So what happens here is that things might change themselves up, and this is where students tend to get a little messy. What happens if this is negative 16 and this is negative 13? How do you set that up? Well, in your calculator, or just by hand, you would be doing negative 13 minus the negative 16. And you just press buttons. Your distances will always be positive, okay? It's not a really big deal. I know you guys have all used a tape measure before, right?
Yeah.
I'd feel weird if you've never used a tape measure.
I have.
What's that? You've never used a tape measure?
Me?
Yeah.
I have.
Oh,
Plenty of times.
You made me worried for a second there.
I haven't. He hasn't.
No. We're already worried about him.
Yeah.
Oh no! I don't know what to do. There's a decimal. Sorry, it didn't show up as well.
Well, it looks like 3.
You're right. Oh no! How long is the segment AB?
4.1. I know.
See if I can make this work.
It's a number.
It's a number. Thank you.
What?
Whiskey, can I have it, please? Oh, sure. Thanks. So you're gonna get up for me.
Yeah. No. Dead mommy. Oops.
Here, will you throw it at it? Maybe you'll hit it. It should work.
What are you doing? Give it to
Yeah, here.
Jason.
I'm not throwing, I'm a catcher. Okay.
Watch it.
It's
Give it to Jason.
Why isn't this working?
Give it to Jason.
I got hit the ball.
Come on, Grace.
You suck. Hey, you better break that.
We're gonna break this first morning. This is gonna be going off on the internet.
Yay! This was a lot more fun though.
Yeah. You guys to go ruin it right now?
So this is what allows us then to be able to do this. It's called segmentation. This is something that you're going to see a ton of. This is something that we use all the time. This is something you actually use in real life, but you just didn't realize you were using it. What segment addition allows you to do is to measure distances between points, like using it twice. For example, would I say that A, B, and C are collinear or non-collinear?
0, 9.
They're collinear because they're all in the same line. Now, can collinear be segments also?
Yes.
So when we say this, it's kind of all goes hand in hand. So segment addition is when you can take, you have to have collinear points. And basically it states that from that whole segment is made up of what two segments? Exactly. That's it. So what happens here is that you'll see that when you have collinear points, you can write that AC is made up of AB plus BC. It is very, very simple to use. One of the things that you will start to see also, or read, is that sometimes they will write out a problem that'll say, you have 3 points, X, Y, and Z that are collinear with Y between X and Z.
Draw the picture.
Draw the picture, and it'll try to figure out a segment length. So, bless you. So if you have 3 collinear points, excuse me. You will see stuff like that all the time. You have 3 collinear points, X, Y, and Z, with Y between X and Z. Or it might say Z is between X and Y. It could have anything like that. But basically, when you see that written and you have to draw it out because you're going to do something with it, it's nothing more than just drawing a segment and putting dots in. Does it matter where you put?
The dot? No.
Does it matter?
That's the reason why you can just like, the reason why you can place the middle dot anywhere on that line segment is because, I'll just give it 2 examples that will tie to the same problem. So say if I have a line segment that's like 8 in width, well, I can put that line segment, say at like at 2.
Yeah, you can put it
so
where
X is at like 0, and then
yeah,
it'll still equal 8.
right.
In the long
The
no matter
idea.
where you put the middle, you'll get the same answer.
Right, it doesn't, and what I'm getting at with where you're going with the middle thing, it doesn't necessarily have to be in the middle. It's just anywhere anywhere in between. It doesn't say that it is in the middle. When we get to it later on, we'll start talking about things called midpoints, and we'll talk about that later. So what we're able to do then is to take something like this and figure out missing parts. Because these style problems tend to lead themselves into very fast algebra. We know that the whole segment is so much. We know one chunk, what's the other chunk? And how do we figure that out?
I already got it.
Oh, and one thing don't yell at me when things aren't drawn to scale. So does everybody see what I'm saying here by this tends itself to show itself into an algebra problem? We know that the whole segment is 36. That whole segment is made up of 2 chunks, 21, and what do you call your unknown? X. You can do that, you can call it question mark, whatever. So how do you solve your one-step problem? Yeah. Now, excuse me, what Mrs. Thrower is putting up there is shown in long form. What's that?
Then I'm just gonna plug in what I know. So I
Yeah.
know that FG is 21, I know that FH is 36, and then I realize that this is just a missing add an addition problem. That's it?
Is it?
That's it.
Is it? It- When we start to write these things out, don't get lost in the lettering. Really, a lot of times you're just trying to solve for that missing segment. It is very, very straightforward. Okay, sir.
So say on the quiz we get ones that have like 4 points.
Mm-hmm.
It's pretty much the same thing but with an extra dot.
Yeah, and I have examples of stuff like that as we go into it. So you'll see how these things are going to work themselves out. I'm not going to mess with those; they're too simple. Oh, scary me! Algebra. Gee, guess where everything goes back to? So wrong button. Let's try one at a time with some algebra. All right. bud. So we start to look at this in terms of segments. These are all just plain old boring segments. There's nothing crazy going on here. We know that it's asking you to find a certain part, the VW. In order to figure out just that one part, how do you set up the problem? What are you going to do first? Is VW the whole segment or is it part of the segment? Part of it. What two parts make up the whole here in this case? Yeah. We know that TV plus VW has to equal what? TW. Now, one thing I want you guys to start to pay attention to is notice you got that shared point in between. You have that shared point a lot of times. It's a nice, easy way to remind yourselves that you're in the right direction. Right? You're on the right path, if you will. So you fill in the blanks. TV is 3x, and an x plus an 8, and the whole thing has to equal 32. So now when you combine your like terms, what do you have to get? 4x, very good. So you wind up with 4x and an 8. Subtract the 8 I heard you mention. Good, good, good.
And then you just put down 24. And then you divide both sides by 4, which x will give you 6.
Very good.
Is that the final answer?
No.
It's not. Did it ask you to solve for x or did it ask you to solve for a part? It asked you to solve for the VW part, which means you have to take the value of x and do what? Very good. This happens all the time in geometry. You will have the algebraic solve for x, but then they're going to ask you to do one more thing. You see it all the time, and one of the things that most students will forget is to do that. So your real answer is 14. One thing that you will see when you start taking like ACTs or SATs and things like that, that's one of the types of questions, one of the things that we'll put in there for one of the multiple choice parts. Your value of x of 6 would be one of the options. Because you're going to say, oh, I just solved for x, there's 6, I'm done, go to the next problem. Instead of being careful and rereading what you had just done and substituting back into the problem. That is a very, very common, what's that word called? It's distractor, thank you. Yeah, it's a distractor. So when you read the geometry stuff, guys, even though you're solving algebra, just make sure you go back and reread the question and see what exactly you're solving for, okay? As you can see, pretty darn simple. So, let's do the other one. Actually, let's put some on the team. Take a second, go for that one. Yes, ma'am. No, you don't have to, but what's nice is if you did that, you can always double check, make sure you didn't screw up. Because if you substitute back in here, you get 18. 18 and 14 should have added 32. Hey guys, great question. Even though on our problem a second ago, we only had to solve for the VW part, I believe. So it was the x plus 8, and the other one was 3x, I think. We knew that x was equal to 6, and we also knew that the whole thing had to add up to equal to 32. So that means if we substitute this guy here, we got 14. If we substitute here as well, we would have had the 18, for 3 times 6. So it's always a good thing just to double check, make sure you didn't screw up something silly, just to make sure it adds up correctly.
Because one of your distractors on that standardized test would be that 18 would be an answer, and so would
Yeah, you'd have an 18, a 14, a 6. Those crazy standardized test people. Excuse me. Did you call that?
Got it.
Okay. I want to give you Cam anyway.
Because then I can never sell my house, let go of it. Well,
Where? Stop. How did the Colts lose? How did the Cardinals lose?
just not in my house.
All right, so what do we do?
Anyone have an answer?
We do math.
XY
XY
plus YZ
plus YZ.
Two X plus 3.
Oh, sorry, I wrote that wrong. I'm sorry. XZ. Okay.
So 2X plus 3. So 3X plus 4 plus 5. So 5X plus 2. 27.
Oh, some nice, fast, easy math here.
Plus 5 plus
Very good.
and you put it into 3X minus 1. So 3 times 5 is 17 times 1.
Double check the other one. Last time I checked, 13 and 14 equaled. Yeah, we math.
X equals
This is where it gets interesting. What isn't on this diagram? What's that? Bless you. I couldn't hear you. There's 4 points, but what I'm looking at here is there's no numerical value given to anything. Guys, come on. So it says that in the diagram, points P, Q, R, and S are all collinear. Oh, there's okay. It tells you that PS is 46, PR is 18, and PQ equals QR. So if things are equal, what would they have in common? If things are equal, let's talk about that real fast here. Yeah, it's the first time this has come up. When segments are equal to each other, that means they have the same measurement. When two segments are equal in value, they have the same measure. So in this case, if PQ equals QR, what we can say then, and this is more of the more geometry version of it, is that when two segments are equal in length, they are congruent to one another. Have you ever seen that symbol before? Yeah. Equal with the squiggly stands for congruent. Congruent segments are segments that are equal in length. Congruent angles would be angles that are equal in length, or angles equal in measure, okay? So what happens here is this congruency is the fancy way of writing it out in terms of geometry. Congruent is just, excuse me, equal measurements. Very simple way to put at it. Equal value. What we're able to do in our diagrams then is that whenever we see things that are congruent, we use what are called tick marks. When I put those little tick marks in, that reminds me that I know now that those two segments are going to be equal to one another. We use these tick marks a ton as we go throughout. For example, when we start talking about congruent triangles, when we have triangles that wind up being congruent to each other in about a month or so, we'll see stuff like this. That means that this segment matches to this segment. The double tick mark matches to the double tick mark. The 3 goes with the 3. That means that these guys are all what we call corresponding to one another. Okay? So we start to see these tick marks more and more and more. So now we go back and we have all the rest of our numbers then. Well, the whole thing was how much? The whole thing was 46. So I could do this. Oops. Say that's 14. And I know that PR, this segment, is 18. And then it said that PQ and QR are the same. Well, what's PQ and QR?
18.
Well, yeah, together they're 18, but how much is each one of them? 9. They're both 9. Very easy. Didn't mean to, you just know that you take half of it because there's 2 of them that together, you have to do the math. So you have 9 and 9. Well, how much is RS then? Bless you. 28, good. So notice, did I even bother to read any of these questions yet? No. And I do that all the time in geometry. I want to fill out my diagrams the best I can before I go to the problems. Because now that I've done all the work on the diagram, I can quickly, well, PQ is how much according to my diagram. QR is how much according to my diagram. QS is how much according to my diagram. 37. And then RS is the 28. Notice I did not have to go back and forth to do the extra math. Whenever you have what we call bigger diagram style pictures, try your best to fill in everything you can before you get to answer a question. It's such a key. Once you get good at that, then eventually we'll be able to do this. You'll be able to go to big pictures like this eventually and just work your way out of one spot. All you need is to know, there's a couple bits of information here. With these arcs, we can find out all the different other angles and arcs that are built into this. We'll be able to figure out segment lengths just from starting with one spot on the diagram and working your way
The
around.
whole circle is 180 degrees.
Now you're halfway there.
360, bro. Oh, 360. Who's this?
Uh-oh. It just got scary. There's no diagrams, and it's all in letters. Uh-oh. But take a look at how it's written. Notice how we've talked about this before. Point B is between A and C on segment AC. Use the information, write the equation, determine specs, solve it, find A, B, and B, C. So if point B is somewhere between A and C, what should you draw? Draw a line segment. Yeah, exactly. Does it have to be perfect? Nope. Starts it out. Now you have a visual. Fill in the blanks. How much is AB? How much is BC?
X. What's your
And then how much is AC?
20. 20.
See how easy it is to work yourself out of it, even though you had no diagram to start with? It is relatively simple, isn't it?
Done. Got all 3 of them.
Smart one.
Guys, enough. The idea here is, guys, is that you're going to be able to take very simple statements and you'll be able to draw very easy diagrams and solve these 1- and 2-step equations without much of a hassle at all. It is really straightforward. So in this case here, we have 3x and x, and it has to equal 20. So what's the equation going to look like when you start to set it up? How do you solve that?
Okay. If
Okay. 3x plus x is 20.
Yeah, so you divide, so you add 3x plus x, that will give you 4x equals 20, divide both sides by 4, x would equal 5.
Yep. Like I said, guys, a lot of these things go real fast, but did it ask you to solve for x, or did it ask you to solve? Solve for specifics. AC and BC. Well, if x is 5, what's AB and BC?
15 and 5.
That's all it is. Okay? This generic setup, you're going to see it over and over and over again with what turns out to be, you know, two-step algebra problems. Okay? It's nothing scary.
26.
Try 27 for me real fast. Please. Excuse me.
Please, Mr. J, and my geometry teacher. Well, students. I like this teacher.
I know. It sounded like a great way to start your day. And it just, I've never done that. Ever. And one of the reasons is that we always had that extra seat in her car, but it's expired by, it's long expired because it can be in a booster, so we just haven't bought another one yet. Gonna be going to buy one today. So again, we know it's AB, BC has to equal AC. And also, what's nice if you start to think about it, if you look at the letters, even if you didn't know that B was in there, doesn't it kind of have to be between it? The way the lettering is written out, it's going to have the whole thing. So we have 4x, a 7, a 5x, a -8, and a 53. 4 plus 5 is? 9x minus a 1. Hey, you guys all know the 9's trick, right? No? You don't know the 9 trick? So it's 9 times 1 is 50. So 1, 2, 3, 4, 5, 6. Here's 54. I always thought it was kind of funny. No? And then it's just a matter of substituting back up. So it's 24 and 7 is what? What is it? 31? 20 minus that then would have been, Hey, look at that, 31 and 22 equals 53. We math correctly. Okay. Let me give you guys some homework problems for this evening.
Hey, Mr. Murphy, while you're in the homework problems, can you tell us your 9/11 story or not?
Not right now.
Okay.
Yeah, I know. Let's see here. Let's do these. This is section 1.2. It's on page 13. Actually, it starts on 12. Real fast. Okay. This is section 1.2. It's on page 12. It's kind of convenient. It's all in there. So on the tab, I'll show you guys again on the website how you look at the book stuff. It's all right there. And then it's just a matter, I'd like you to do those. I think it works out to be, what is that, 15 maybe? It's just some real quick algebra stuff just to get going through on there. All right. So again, we're at the website here. I'll put that in our calendar for the assignment. I don't have it in here yet, but I will type that in here now. And then we are chapter 1. And where do you think would be a good place to find the textbook?
At the top of the page.
Where it says, click me for the textbook. And then you have to go through the front page. And there it is. Okay? It's just a pop out on a PDF. Okay? Sir. Oh, trying to stab me. Thanks. Appreciate it.
No problem.
Yes, ma'am.
We have a calendar.
It's nice when you do something that works out pretty easy.
But go back.
Okay, those of you who have not been keeping up with homework, this is going to bite you in the butt on Friday
You scroll down.
if you don't keep up this week. Heidi and Marty.